Hi, David Ken here with another question from the question bank in the style of what you find in your Hayes and Harris Math SL textbook in Chapter 6a. In this question, we're given a function, 2x squared plus 4x take 6, and we're told to express it in a different form. This is a vertex form, where h and k give us the coordinates of the vertex of the parabola. Another way we can think about this form is that it's also very similar to completing the square. So we're going to use a similar method to completing the square to transform this equation into one that looks like this. So let's start with f of x equals 2x squared plus 4x take 6. Now I notice that I want a 2 factored out of any term with x. So I'm going to factorize out a 2 from the first two terms. 2 out of 2x squared gives me x squared, and 2 out of 4x gives me 2x. Now I want to turn this into perfect squares, so I'm going to leave a little blank in there. And I'll leave my 6 alone. So I won't factorize 2 out of the 6, although that is something that could be done. I'm going to choose not to. Now I'm going to attempt to use completing the square, so I'm going to say that I want this to be of the form a squared x squared plus 2abx plus b squared. If it's of this form, then a must be equal to 1, and 2 must be equal to 2ab, which means that 1 must be equal to ab, but I know what a is, so 1 must be equal to b. Knowing the value of b, I know it belongs here, b squared. So I'm going to say this is equal to 2 times x squared plus 2x plus 1 squared. Now that imbalances the formula. So I need to rebalance it by undoing that change. Well, what change did I make? I took 1 times 2 and added it into the formula. So I'm simultaneously going to subtract the same thing to make sure that the equation stays balanced. So now that I've done that, what I have is perfect squares in the center. It's x plus 1 squared. Out here I have negative 6 take 2. That's negative 8. And that's f of x in vertex form. Part B says to write down the equation of the axis of symmetry, and I can use the equation in vertex form to help me do that. Here I see that my function is really just a graph of x squared, which has been transformed. X is transformed by x plus 1. Then I multiply 2 by it. Then I subtract 8. These are 3 different transformations to create f of x. So when I take a quick look at what this does to f of x, I start with x squared. And the first thing that happens to it is it gets shifted to the left 1 unit. Then it stretches vertically by 2, and then it shifts down by 8. So that's negative 1, and that's negative 8. And that's my new parabola. So where's the axis of symmetry? It's right through the center. And what is the equation of this line? Well, it's not negative 1, because negative 1 is not an equation. It's the equation x equals negative 1. And you won't get this 1 mark if you don't say x equals negative 1, because it asks for the equation of the axis of symmetry. And the equation of this vertical line is all of the coordinates on the Cartesian plane for which x equals negative 1. All right, part C says, now express f of x in the form 2 times x take p and x take q. And this is the form that gives us the zeros. But we'll see how we can transform the function f of x. We'll start with f of x, which is equal to 2x squared plus 4x take 6. And I notice that a 2 is factorized out of the whole thing. So I'll factorize out a 2 from every term this time. Last time I left the 6 out, but this time I'm going to include it. And now I'll see if this factorizes. X squared, I don't have many choices if it's going to factorize cleanly. It's got to be x and x, and I'm told it has to be x and x. But the question is, what do p and q need to be? Well, negative 3 can only be positive 1 and negative 3, or positive 3 and negative 1. That is, if it's going to factorize cleanly. I want more positive numbers than negative numbers, so I'm thinking plus 3 and negative 1. We'll see if that works out. 3 times negative 1 is negative 3. X times x is x squared. 3 times x is 3x. Take x is 2x. And I think that'll be f of x in this form.